Good morning, good afternoon, and good evening. Those of you who watched my last video, number 39, will recognize this new trend power bank. And I said that I might use the enclosure to build my own more modern power bank. For various reasons, I'm not using the battery pouch that I recovered from it. Instead, I'm going to use these 8 cells that I've recovered from the vape smoking gadgets. I'll be connecting these 8 batteries in parallel for a total of 10,000 milliamp hours. So this is a closer look at the power bank. These are the 8 cells, and this is the board, which I purchased from AliExpress. And you can see that it has multiple outs, 2 USB-A, USB-C, and I believe that's a lightning port. And it even has this temperature sensor here, which I believe basically you attach it to the battery cells, and if the cells get too hot, it probably cuts the amps. It reduces the current. I used some Kapton tape to hold the battery, 4 batteries together, and the same with the other 4. And the plan is basically to solder a wire all the way through here, and then solder another wire all the way through here, all the way through here, and do the same for the other set. So now I'll be left with the 2 sets, and then I need to also make these in parallel, knowing that in the enclosure they're going to be placed like this. So we'll connect these together somehow. I'll put a little wire from this end to this end, and then probably a wire from this end all the way to this end. So then we can get the benefit of 8 cells in parallel. Here I'm just checking the voltage on each cell, 3.84, and charging them all to be 3.9 using my these probes are my bench power supply, and so I'm charging them all to be around 3.9, 3.95. Because they are all in parallel, it's good to have them all at the same level before connecting everything together. So this is what I have so far. I've soldered a wire across the positive terminal and did the same to the negative terminals, and also for the second battery, same thing. Now I'm going to put a link between the 2 negatives here. I'm going to put a link so then I can move this one up and place it on top like this, so that this will fit in the enclosure. So that's what I'm going to be working on next. It's been about 30 minutes and I now have the battery ready. This is the negative terminal, and I put all the negatives together here, and then this heat shrinked wire connecting all these positives, all these positive terminals here that are connected to these positive terminals via this heat shrinked wire. And so now I need to connect this negative to the board, the charging board's negative, which happens to be a blue cable, and I added a piece of heat shrink to heat shrink the solder point. And then the red lead I need to solder to the red wire coming out of the charging board. I've soldered on the negative and positive. I still haven't taped the heat sensor, but I want to do some testing, a bit of testing, before I try to put it in the enclosure. So here we go. There's the button here. Okay, I can see the light. Let me turn it over. The lights are on the other side. Let me bring it closer so you can see the lights. Okay. So let me charge. What am I going to charge? Let me charge. I'll use the fan. So we're going to try on the fan. Here we go. And let's see what happens. Yeah, the lights came on and this thing is charging. Let me bring in my meter so we can see how much it's drawing. There we go. It's charging with 190 milliamps at 5.19 volts. Okay, next I'm going to use the USB-C cable and try to charge something. Alright, it was a bit hard to get everything into the frame, but I think I've managed it. So I've connected the USB-C to the in of this meter, and then the out I'm going to connect to my phone here. Yeah, there's fast charging. Where is it? Fast charging, 28%, and the red charging light is on at the top of the phone. And it's charging at 4.94 volts, 1.67 amps. I'm going to try to charge battery bank using USB-C. Oh, it's cutting off. That's the behavior I was seeing with the other battery pack. That's why I decided not to use it. And now I'm seeing the same behavior with this battery pack. Let me show you what's happening also on the meter. So watch. It goes to 8.9 volts at 1.9 amps and it cuts off almost 2 amps. And here also the lights come on, starts to charge and cuts off. So I just tried the same battery bank with another board. I had bought 2 of them, and I'm seeing the exact same behavior. It cuts off charging. So I don't know what the deal is. I'm still going to post this video, but unfortunately it's a failure. Well, hello again. It is the next day, and let me show you what happens now. I'm going to plug in the USB-C. So now it's charging without resetting, and it is fast charging. I will move the camera to show you the meter. As you can see, it's charging, and here is the meter. 8.8 volts, 1.8 amps. Still charging. You can see the meter is not turning off and resetting like before. Okay, I'm going to bring you back to the board. There we go. Still charging, no issues. So the problem basically was these. These are basically cheaply made power supplies, and they were basically over current. There was too much current being drawn, I guess, and they would just turn off. So I replaced them with, we can't see the marking, it's on the other side, but this is a genuine Samsung phone charger that supports fast charging, like quick charge, whatever the Samsung supports. And it's doing fine at almost 8 volts and 1.7 amps. And it's working well. So that's all it was basically. The need for better power chargers. So I'm glad I could bring this to a successful close. The only thing left would be putting it in the enclosure and sealing the enclosure. And I'll also tape the temperature sensor somewhere here on the battery in case it gets hot. Short voiceover. This is the assembled power bank and the close-up of the ports here, and a short video of the charging process. The LEDs actually show clearly in real life. Anyway, I hope you enjoyed this video on project, and see you on the next one. Bye bye.